Hello everyone, I am Dr. Professor Department of Pharmaceutical, SKB College of Pharmacy, and I am here today to deliver a lecture on optimization technique and statistical designs. So let's see. Basically the question generally asked is what is experimental design? In an experimental design, we deliberately change one or more process variable or factors in order to observe the effects the changes have on one or more response variables. Experimental design economically maximizes the informations. The design of experiment is an efficient procedure for planning experiments so that the data obtained can be analyzed to yield valid and objective conclusions. Well chosen experimental design maximizes the amount of information that can be obtained for a given amount of experimental efforts. Design of experiment begin with the determining the objective of an experiment and selecting the process factor for the particular study. So basically optimization is a process of finding the best way of using the existing resources while taking into the account of all the factors that influence a decision in any experiments. So in a nutshell, it is nothing but choosing the best element from some set of available alternatives. And I say that it is a basic process to make anything perfect. The term optimize is to define, it is defined to make perfect, effectual, faultless and functional as possible. It is a process of finding the best way of using the existing resources while taking into account all the factors that influence the decision in any experiment. Optimization in pharmaceuticals basically refers to changing one variable at a time so to obtain the solution for the challenging formulations. Modern pharmaceutical optimization involves systematic design of experiment, we generally call this DOE, to improve the formulation irregularities. Now, why optimization is necessary? Basically, it helps in cost reduction, safety, less error, time saving, and reproducibility. Basic objective of pharmaceutical optimization is to determine the variable, then to quantify the response with respect to the variable, and last we find out the optimum. What are the basic advantages? The advantages are to yield the best solution within the area of experiment, require the few experiments to achieve an optimum formulation, easy to trace and rectify the problem in better way, and last is cost and time saving. The basic terms which are generally used in optimization or in experimental design is factor. It is an assigned variable such as concentration, temperature or any other factor. It may be quantitative or may be qualitative in nature, maybe in the percentage or maybe which are not in numerical unit. Example, polymer, grade, types of excipient and etc. Second is the level. Level of factors are the values or designation which are generally assigned to the factor. It may be temperature like 20 degree, 30 degree, 50 degree and so on, concentration and pH. Another is response. It is basically an outcome of the experiment. It may be like hardness, maybe disintegration time, maybe release rate, etc. Effect, it is the change in response caused by the varying the level. It gives basically the relationship between the various factors and various levels. And last is interaction, which is a very important part. It gives the overall effect of two or more variables. That is what is the combined effect of lubricant and chlorant on the hardness of tablet. So basically optimization parameters are of two types. Maybe it is defined as a problem type or maybe a variable type. Problem types are of two types, constant and unconstant. And variables, there are also two types, may be defined as a dependent and independent. When we talk about the problem type, it may be unconstant and may be constant. In unconstant optimization problem, there are no restriction, like we have to make the hardest tablet or we have to prepare the viscous preparations. In constant, it involves certain constant in it, like to make the hardest tablet, but it may be disintegrate in 15 minutes. Variables may be of two types as we have discussed earlier, independent and dependent variables. Independent variables are under the control of formulator like filling of dye cavity, type of polymer, compression force, mixing time, etc. And dependent variable are the responses or the outcome that are developed due to the independent variable. The more the variable that are present in the system, the more complications that are involved in the optimization technique. So optimization parameters related with the relationship between the independent and dependent variable, as we have discussed earlier, representing greater than 2 makes graphically it is very impossible. Higher the variable, higher the complication. So response surface representing the relationship between the independent variable and the dependent variable, that is the response. As you can see in the graph, x1 and x2 related with y, that is called as the response variable. Now classic optimization involves the application of calculus to the basic problem for maximum and minimum function, but it has a limited applications. Problems that are not too complex and that do not have more than two variables, we can use this. But for more than two variable, graphical presentation is very complicated and impossible. Using calculus, we can solve this with the help of regression analysis. Now, what is statistical design? Now, basically, statistical design is technique divided in two types. Maybe experimentation is continued as optimization proceeds, as EVOP, that is called as evolutionary operations, and simplex method. And second is experimentation is completed before the optimization takes. That is, it is represented by the classical mathematics model, and second is search method. For the second type, it is very necessary that relationship between any dependent variable and one or more independent variable should be known. There are the two possible approach. One is a theoretical approach. If the theoretical equation is known, no experimentation is required. And second is the experimental approach. It is also called the empirical method. With the single independent variable, formulator experiment with the several levels. So we will discuss about the various type of experimental design, like completely randomized design, completely block design, factorial design, full and fractional, response surface design. It may be central composite, box bracket, and 3-level and 2-level full factorial design. Choice of experiment basically depend upon the knowledge level and generally the resources available and objective of experiment. For example, discovering the important factor, we can go for the Plackett-Berman fractional factorial. For estimating the effect and interaction of the several factors, we can have full factorial and the fractional factorial and Tekochi design. For optimization, yes, we can go for the central composite, simplex, lattices, d-optimal and box bracket design. Now, factorial design is an experiment whose design can consist of two or more factors, each with different possible values or level. This is generally introduced by the Fisher in 1926. Factorial design applies in the optimization technique. Factorial design depend on independent variable for development of new formulation, and factorial design also depending upon the level as well as on the coding. For example, we can have coding such as levels such as low, intermediate and high, and coding such as -1 for the low, 0 for the intermediate and +1 for the high. So this is regarding the basic of optimization and statistical design. Hope you have understand about the optimization, and thank you so much.